this is the product rule of derivatives, and this is the proof. This minus this is delta f. Therefore, this equals f of x plus delta f. F prime of x equals the limit of this as delta x approaches 0. That is, this is delta f over delta f over delta x. When the delta x approaches 0, f prime of x equals delta f over delta x. Therefore, delta f equals f prime of x times delta f, delta x. This will be used in the proof of the product rule later. So, as before, this minus g of x equals delta g, and this equals g of x plus delta g. G prime of x equals the limit of this as delta x approaches 0. That is the limit of delta g over delta x as delta x approaches 0. When delta x approaches 0, g prime of x equals delta g over delta x. Therefore, delta g equals g prime of x times delta x. Okay, then we have the prime of f of x times g of x equals the limit of this as delta x approaches 0. This is the definition of the prime of this. So this, and we know that, as we know from above, that f of x plus delta x equals f of x plus delta f, and this is g of x plus delta g minus this over delta x. Then we do the cancellation. Then we get this delta f times g of x plus f of x times delta g plus delta f times delta g over delta x. As delta x approaches 0, then the limit of this is this. Delta f over delta x, that is the f prime of x, times g of x plus f of x times delta g over delta x, that is g prime of x, plus this delta f. Delta f equals f prime of x times delta x, and the delta g equals g prime of x times delta x. So this is this, and the limit of this as delta x approaches 0, these are two cancelled, and delta x is 0, then this is 0. So the result is this plus this. Proved.